Data-driven decision-making isn't a new phenomenon that was invented by algorithms and science types. For millennia, humans have used observation and evidence. As this is my first video I've done, and it was a lot of fun, and I learned a lot from my goofs. I'm just asking for criticisms and critiques, except for my green screen edits. I know those need work, and my mumbles. Okay, back to that guy. He actually gets less fuzzy as he goes on. Thanks. Conquer the world's greatest unknowns. And to show this evolution, we're going to go back in time. I mean, like literally. Because today I'm traveling through time and space to examine 5 landmark data-driven methods and decisions where innovators face some of humanity's greatest mysteries, sometimes not even knowing they are mysteries. These are the stories of individuals who chose observation and evidence over tradition and assumption, from sizing the ground beneath their feet to mastering the cosmos. These breakthroughs changed our world, and that's why I'm interested in them, because I'm data-driven Doug, and my mission and my calling is to cut through the noise on curious questions, dubious decisions, and let you know about medication magic, but always with data and science, using published research and documented facts. I'll explore the burning questions and seek to provide you answers. And if you like seeing this or the data behind everything from how medication works to the best way to win a baseball game, then prove your dedication to the data and subscribe. But let's begin our examination at the very dawn of systematic inquiry, as long as my time machine works. That was a tough landing. So wow. So my journey begins in the ancient world with a monumental geographic mystery, and that's how big is this big old rock we're living on? Because for centuries, mathematicians like Aristotle and Plato, they accepted an estimate that the circumference of the Earth was 400,000 stadia, which is the rough equivalent of about 74,000 kilometers. The stadion is a unit of measure they actually based on the nearby sports arenas. The length of one lap was one stadium. Eratosthenes was determined to ensure the measurement was accurate. He planned to verify through both the distance between the two cities and by measuring the sun's angle as it cast a shadow upon those two cities at a precise time. And I apologize for the low quality pics, but I really can't find any good HD images from 240 BCE. So we have Eratosthenes, and he was operating from Alexandria. And well, he's going to be the head librarian of the Library of Alexandria someday, but don't tell him. Spoilers. But like most librarians, he did this logically. He knew that he was 5,000 stadia away from Syene, which is modern-day Aswan in Egypt. And in Syene, at high noon, the sun was directly over the well of Syene, casting no shadow in the waters. It was straight up. I know that sounds weird, but it's a huge well. But on that same day and at the same time, but in Alexandria, he measured the shadow cast by an obelisk, finding it to be 7.2 degrees away from being straight up. His breakthrough insight was realizing that this 7.2 degree angle, which was caused by the Earth's curvature, technically continued to the center of the Earth, making a very nice 7.2 degree slice of pie. No, not pie, pie. Also, 7.2 degrees is exactly 1/50th of a 360 degree circle. Therefore, if the distance between the two cities was 5,000 stadia, if you multiply that result by 50, you're going to get the distance around the entire globe. And using all that information, he arrived at the result of 250,000 stadia, or 40,000 kilometers. And by the way, the circumference that we have at home is 40,075 kilometers. That is a stunning 99.8% accuracy. And look what happens, though, when you rely on math and not myth. Very nice. This foundational belief in rigorous mathematical methodology was essential to solving great unknowns. Across the globe, however, this focus on objective measurement wasn't just done for science's sake alone, instead, focusing on immediate, catastrophic problems like determining the source of violent earthquakes. Seriously, though, I am a little worried about getting there with all this sand in my time machine. Ooh, nice. I'm actually, that was a good one. Hey. Ugh. Whoa. Ah, that's okay. That's why I'm here. Because, mathematicians in the West, they use geometry to measure the entire globe. But engineers in the Han Dynasty in China were applying physics and data collection for a very, very severe issue. Um, Earthquakes were and are random, unpredictable, offering no immediate data on their direction or their origin. And Zhang Heng was the genius who faced this colossal problem. The problem was, by the time the centralized government would learn about a disaster, they were not rapid enough in their response, and they needed to be faster for their people. So around 132 CE, he invented the Hofeng Didongyi, which translates to an instrument for measuring the seasonal winds and the movements of the earth. Basically, the world's first earthquake detector and monitoring system, a seismoscope. In that the peeps in Europe did eventually figure it out, like 1700 years later, give or take. That depends on how you define it. But this intricate bronze vessel used an internal pendulum, and when a tremor occurred, the pendulum's inertia would cause a lever to tip a ball from one of the 8 external dragon mouths into an awaiting frog mouth below. And each frog indicated a compass direction so they had a better idea where the tragedy struck. Hang on. His data was the objective signal generated by the mechanism, a ball dropping and indicating the directional data on the quake's origin immediately after, and well before a messenger could ever reach them. And his data-driven decision was the rapid, targeted dispatch of aid to the region that was indicated by the directional frogs. And this was a triumph of systematic mechanics over guesswork, ensuring a rapid, data-driven response to that disaster. And when he had time, he checked out my time machine and fixed it even. So I think I should be good. Yes, nice, landing. Hope I can go backwards again, or maybe get my shoes, or get this fixed, or maybe talk to one of their optometrists or something. Because for over 1,000 years, thinkers like Ptolemy, they claimed that I worked by emitting rays of light, or flux as he called them. These rays struck objects and sent the information back to your brain. Little laser beams that come out of our eyes. They hit a vase or something, then you see the vase, like a weak version of Cyclops. No, not that one. Yep, that one. Ibn al-Haytham, operating from Basra, which is a city in Iraq, turned his attention to the mechanics of sight. He applied a methodical experimental process, recognizing that he can only really verify things if he can observe and repeat them. See the pattern here? He began a series of meticulous experimentation that had proved foundational to the modern scientific method. He used a dark room with a teeny tiny pinhole. You may have heard it called a camera obscura. He recorded what happened when light passed through that itty bitty pinhole. His data was the inverted image he observed. The light rays crossing the tiny pinhole caused the projected image to be completely inverted on the back wall. And that can't happen if you have laser eyes. This inversion was a critical data point. It demonstrated through geometry that the light rays must travel from the object into the chamber. And this crucial evidence proved that the ancient idea that the eyes sent out rays was just wrong. They became a logical plausibility due to his experiments. And that's a good way to actually show how science works. You learn, you study, you evaluate, and when you find out something is different or new or wrong, you do it again and you reevaluate. And it's amazing. His data driven decision was the shattering of the emission theory and establishing that light rays actually travel to the eye from external sources. He was the first to formalize a process where theory must be derived from and tested by systematic, repeatable observation. This was truly a revolutionary step because he was an early pioneer of the scientific method, and that is a hypothesis or an idea must be supported by data or evidence. He's truly my spirit animal. But thousands of miles away, other civilizations were also proving the power of methodical, long term data collection to, in this case, master the universe. I really can't focus on a person anymore. I must have really busted this bad boy up. So hang on. I feel like Al from Quantum Leap. Gushy! Ooh, yeah, I think this is right. I'll just need to be close because these boos apparently do not like outsiders. So, well, I don't know if it's going to work. Well, I'll just be sneaky. Speaking of sneaking in segues, remember when the world was going to end that time? No. The other time, the Maya calendar thing in 2012. They weren't wrong, by the way, because they weren't predicting the end of the world. It was just time to get a new calendar, and Chichen Itza has no Hallmark stores. So most people know about that pyramid that I just came from, but this is where the Maya astronomers worked. Wait, it probably worked third shift. There we go. To predict the movements of time itself, the Maya civilization undertook a massive, multi-generational data project. Even though they probably didn't call it that, but they extensively and continuously refined their astronomical knowledge from like basic horizon tracking and estimating the moon's cycle to addressing the prevailing mysteries of the seemingly chaotic and random nature of the sky. The results were astounding. Their data-driven achievement was the creation of a calculated, predictable cosmic schedule. This continuous refinement allowed them to precisely determine the occurrence of future celestial events, for example, eclipses or where Venus would be in 3 months. And this was based on their cumulative records rather than observation alone. And regardless of their eschatological failures, their calculations were more accurate than any contemporary system in the world. They proved that persistent, systematic data collection could reveal the highest order of cosmic mysteries. And this same commitment to systematic data, often unwritten, was critical also to conquering the world's vast oceans. That's a transition. And let's hope that that thing gets me there. Wow. Ooh, it's paradise, right? Now, if you don't know where you are or where you're going, because the final unknown involves mastering one of the Earth's largest features, and that's the open ocean. Polynesian navigators conquered the vast distances of the Pacific through observational data. Pretty similar to the Maya, but they are more concerned about 3-hour tours instead of the third rock from the sun. Starting from modern-day Taiwan, it's speculated that the techniques they created helped to spread their population throughout the Pacific, which is pretty huge, by the way. Older methods, they weren't that great. They relied on hopefully seeing where you were going, or coastal piloting. It's where you would go from one land-bound landmark to the next. Or risky dead reckoning. It estimates position and projecting speed and direction from a location. Yeah, these methods would often fail over long distances. It's like trying to play Mario Kart with your eyes closed. Ooh. The Polynesian navigators did not rely on written maps, but on an encyclopedic knowledge of natural observations passed on through generations, basically through word of mouth. This data included the fixed paths of hundreds of stars, the subtle reflection of land masses and cloud formations, and even the complex patterns of the waves as they refracted off the different islands. And even neater than that is how they recorded it. I know I said they didn't write anything down. I wasn't fibbing. Check this out. They're not maps in the modern sense. Instead, they're mnemonic devices and ocean navigation models. The stick and shell charts used by these navigators, they're fascinating. They chart ocean swells and currents, be more concerned how the waters flow around an island rather than a scale image of the island itself. The sticks would be arranged and secured together, and that would represent how the water was flowing. Their data-driven method was the precise calculation of course and location over thousands of miles. Their verifiable success in settling nearly every habitable island in the Pacific stands as a testament to the power of human ingenuity and rigorous systematic data collection. Now, hopefully we'll have some rigorous time travel as I try to get home. Ooh, well, that's a problem for later. But at least I got to 5 moments in history, 5 colossal challenges, and in every single case, the answer wasn't found in myth or guessing, but in the rigorous, irrefutable power of data. And you know what? If you want more historical scientific explorations like this, hit that subscribe button now. Do those things. But the one thing you shouldn't do, don't guess, data test.